Good afternoon, everyone. Now we start the numericals from the article center of mass. We are coming to the last session of this chapter, center of mass, and only the numericals part is remaining. The first part of the numerical, that is the center of mass. First we see what is the meaning of center of mass before solving the numericals. Center of mass is an imaginary point where entire mass of the body is supposed to concentrate it. That imaginary point is called as the center of mass of the body. For some bodies, center of mass lies inside the body, and some bodies, the center of mass lies outside the body. The center of mass of the body depends upon the masses of the particles, then the positions of the particles from that imaginary point where entire mass of body is supposed to situated, then the relative distance between the particles, and remember that center of mass never depends on the forces acting on the particles. Okay, it will be depends on the masses of particles, then secondly the position of particles from that imaginary point, and then the relative distance between the particles. On these three factors the center of mass of a body depends. And for some bodies, the center of mass lies inside the body, and some of the bodies, the center of mass is lies outside the body. Just see the one example. This is the one simple T-shaped rod is there. Means this is the one combination of the rod, one vertical rod and one horizontal rod. Now here the center of mass is situated along the horizontal axis. Here the center of mass of the body is situated. If I change the position of the rod, if I held the rod in this way, then the center of mass is situated at this particular point. Okay. In this way, as we change the position, the center of mass it will be changed. Now, the simple formula for center of mass is, let this is the one body, and there are some masses M1, M2. These are the masses, and here the entire mass of this body is supposed to situated. The first mass is situated at distance r1, second mass is situated at distance r2, then the center of mass is given by, everyone know the formula, center of mass is given by m1 r1 plus m2 r2, this divided by sum of masses, that is the m1 plus m2. In the same way, we can also calculate the center of mass for x-axis, for y-axis, for the z-axis in this way. Now come to the one simple example. So we get the clear idea how to find out the center of mass. The example is like this. This is my x-axis, y-axis, origin. A be one point, B be the one point. At the point A, mass M is situated. At the origin, mass M is situated. And at the point B, mass M is situated. Okay. Now this distance is given, this distance is A and this distance is B, and the question is find out the center of mass. Okay, and here the distances are given. It forms a one triangle OAB. This is a one triangle. Here OB equals to B and the OA equals to A, and we have to find out the center of mass. Okay. And for this particular triangular body, that is a very simple. Here we have to write down the xy coordinates for the point. This is the value along the x-axis and value along the y-axis. Point is O, where mass is M is situated. This is at the origin. Therefore, from x-axis its value is 0. From y-axis its value is 0. Then come to the A, whose mass is M. A is situated at a distance small a from the x-axis and 0 from the y-axis. Okay, so its coordinates are A and 0. Then the mu is a B. Its mass is M. At the point B, mass M is situated. Its value from x-axis is 0, and from y-axis it is at a distance of B. So we are getting the coordinates of O, A and B are 0, 0. For A, coordinates are A, 0, and for B, the coordinates are 0, B. Now we have to find out the center of mass. Center of mass, its coordinates along x-axis equals to first mass is a m into x1 plus second mass x2 plus third mass x3 divided by sum of masses, that is a m plus m plus n. So x coordinates of center of mass equals to the first mass at the origin O, its mass is m, its coordinates are x1, second mass is at B, its coordinates are A, third mass 0, and the sum of masses is 3m. So we are getting it's a m divided by 3m, that is a 1 by 3. And if you want for the same along the y-axis center of mass, it will be, it is very simple, again m into y1 plus m into y2 plus m into y3, this divided by m plus n, that is the sum of all masses. Then m as it is, y1 is 0, m, y2 is 0, m, y3 is b, this divided by 3m. So ycm equals to m divided by 3m, that is equals to 1 upon 3. If you want to write these this center of mass in terms of its coordinates, then it will be very simple. So here A is remaining and here B is remaining. Okay, so A by 3 and A by 3. So the coordinates of center of mass are expressed in this way: A upon 3 I cap, because I is a unit vector along x-axis, plus B upon 3 Z cap, or in simplest way AI cap plus B Z. In this way we can find out the center of mass of the body. Just see, is it clear for all the members? Is it clear for all the members? We can express in the simplest way. Okay. Now we come to the one more example. We are taking the examples from worksheet. The worksheet is already given to you. There is taking the 4 to 5 examples and then stop it. Now take the one more example. 3 particles of masses A 1 kg, 2 kg and 3 kg are situated of an equilateral triangles of sides B. Okay. Again, in a vector form they are asked equilateral triangle is there. So I will draw one equilateral triangle. This is the OAB or ABC is my equilateral triangle. Each side is of B because it is an equilateral triangle. At the masses are situated, that masses are 1 kg, 2 kg and 3 kg. Here mass is situated 1 kg. At the point B, mass is situated at 2 kg. At the point C, the mass is situated, that is a 3 kg. And now we have to find out the center of mass of this given system. So first of all, we have to write down the coordinates of the point A, then a point B and the point C. Now we have to express in different. Okay. A, its mass is how much? It is of 1 kg. Mass of B is a 2 kg. Mass of C is a 3 kg. Its coordinates along x-axis and the y-axis. Now the 1 kg mass is situated at a 0 distance from a x-axis and from a y-axis. Mass point B, whose mass is a 2 kg, so at the point B mass is a 2 kg, it is situated at a distance B from the x-axis, B from the x-axis, and from the y-axis it is 0. For the C, the last point is the C, whose mass is of 3 kg and its coordinates are, C is situated, if I draw this in this way, AB is of B. So this point is half of the B. So this distance is a B by 2. So from x-axis it is situated at a distance of B by 2. This total distance is B. This distance is a B by 2. So we have to find out this distance. Okay, this distance. So it is very simple. We can use the Pythagoras. If I use the Pythagoras, then I am getting the distance from the y-axis. Same distance from the y-axis. This distance is b. This is the b by 2, and we have to find out this side. This side is nothing but it is the this is the b square minus b by 2 whole square. Okay. So I will write here b square minus b by 2 square. This is equal to b square minus b square by 4. It becomes a 4b square by b minus b square upon 4 equals to 3b square by 4. This is the square of the side, and the total value becomes root 3 times of b by 2. This is my the value. Okay, root 3 times of b by 2. So root 3 times of b by 2. These are my coordinates of the point C. Now we have to find out the center of mass. Again, it is a very simple. Along x-axis, center of mass is very simple. Mass into distance from x-axis, because we are taking this. 1 kg is situated at a distance 0, plus 2 kg is situated at a distance b, plus 3 kg is situated at a distance b by 2 divided by sum of all the masses, that is a 1 kg plus 2 kg plus 3 kg. So the total answer becomes a 2b plus 3 by 2 times of b and whole divided by, it becomes a 6. So at the last step, here the denominator is 1. Now we have to solve this. 4b plus 3b, it becomes a 7b divided by 12. This is center of mass along the x-axis. So coordinates along y-axis are again mass 1 kg situated at distance 0 from y-axis, mass 2 kg situated distance of 0 from y-axis, plus mass 3 kg situated at a distance b root 3 by 2 upon the y-axis divided by sum of all the masses. So again we are getting it's a 0 plus 0. Yes or no? 0 plus 0 plus it becomes a 3 root 3 b divided by whole divided by 2 and it divided by 6. So it becomes a 3 root 3 b divided by 12. So it's very simple. The center of mass is situated, the center of mass, its coordinates are 7b divided by 12. This is along the x-axis, plus 3 root 3 by 12 b along the y-axis. So I cap is a unit vector along x-axis and the j cap is a unit vector along the y-axis. In this way, we can easily calculate the center of mass of this system. That is, your answer is very simple. Your answer is 7b by 12 and root 3 by 3b by 12. That is the first option. Now, in the same way, we can find out if only the coordinates are given, then we also calculate the center of mass. So we see one more example. So we take one more example to find out the center of mass. It is very simple. This part is very easy to find out the center of mass. Some theoretical questions are there. Remember that for a bangle, the center of mass is always outside the surface, or that rim is there and the center of mass is outside. Now my next question is that the center of mass of three bodies, each of mass 1 kg, are located at the points 0, 0, 3, 0 and 0, 4. The coordinates are 0, 0, then the 3, 0 and 0, 4, 3, 0 and 0, 4. And now we have to find out the center of mass. Now it is very simple. We have to calculate the coordinates of center of mass. So along x-axis, the center of mass is given by each of mass 1 kg. Its mass is 1 kg. The three masses are there, each of mass 1 kg. So 1 into 0 plus 1 into 3 plus 1 into 0. This divided by 1 plus 1 plus 1. So it becomes a 3 divided by 3. It becomes a 1. Along the y-axis, the coordinates are 1 into 0 plus 1 into 0 plus 1 into 4. This divided by 1 plus 1 plus 1. So your answer is a 4 by 3. So final coordinates are 1 I cap plus 4 by 3 0. These are the coordinates of center of mass along the x-axis and the y-axis. That is 1 and 4 by 3 are the coordinates, and in a vector form we can express in this way. Okay, this is your simple answer. And if you write the coordinates, then it will be the text or just only the bracket. You have to mention the coordinates of the center of the mass. Now in this way we can calculate the center of mass of the bodies. Now one more question is that we discussed, that is a theoretical question is that a cricket bat is cut at the location of its center of mass as shown in figure. Okay, this is one simple cricket bat is there, and this bat is cut. This is our cricket bat, and this bat is cut exactly at the center of mass. So it forms the two parts. If I cut exactly at the center of mass, then it forms the two parts. This is my part 1 and this is my second part, that is the part 2. These are my two parts, and the options are given. A cricket bat is cut at the location of its center of mass as shown in figure. The two pieces will have the same mass. If I cut this bat exactly at the center of mass, then the question arises, mass of part 1 and mass of part 2 both are same. Okay, first option is that mass of part 1 and part 2 is same. This is the first option. In short, I will write the option. Second option is that the bottom piece will have the larger mass. Okay, bottom piece means which one? That is the part 2. Okay, part 2 have the larger mass. Then third option is that the handle piece will have a larger mass. Handle piece means part 1 have the larger mass. And last option, it is always totally different. Mass of handle piece is double, means mass of part 1 is always double of the mass of part 2. These are my four options. The question is very simple. Just we take one cricket bat, find out the center of mass of that cricket bat and cut that bat exactly at the center of mass. Then we are getting the two parts of that bat. And the question arises, which one is the correct option? The mass of part 1 and part 2 are same. Bottom has a larger mass, means this part 2 has a larger mass. Third option is a part 1 has a larger mass. And last option is a mass of part 1 is double the mass of part 2. Okay. First, concentrate on the definition. What is the definition? Definition is like this: imaginary point where entire mass of the rigid body is supposed to concentrate. This is not a fixed point. It will be depends on the relative distance between the particles, then the position of the particles from the center of mass, and third one is the mass of the each particle. Okay, there is not such a uniform distribution, is no any idea is given in this case. Then what is the correct answer? First we find out which are the wrong options. If you observe very carefully, then the first option is totally wrong. Mass of part 1 and mass of part 2 is the same, because if both the masses are same, then the center of mass is exactly situated at the center. Just see one more example. Suppose I have one rod, okay, and this is the one thin uniform rod. If the rod is given or one scale is given, and it will be held that rod is in horizontal position, and the question is asked, what is the position of center of mass? Then answer is very simple. Exactly at the center, the center of mass is located. Means the mass of rod is balances at one single point. That single point is present at the center. Suppose the length of rod is 100 centimeter, then center of mass is situated exactly at 50 centimeter in this way. But here the center Here the center of mass is not exactly at the center, therefore mass of part 1 and part 2 is same. It is a totally wrong answer. The last one is also wrong. Mass of part 1 is double the mass of part 2 because there is no any mathematical logic. There is no given area, no length is given, no any dimensions are given. Therefore the last option is also wrong. Now come to this one. Bottom part having a larger mass, handle part, that is the first part, having the larger mass. Then which one is the correct? Here, when you observe the cricket bat very carefully, you always remember that here the center of mass is situated. Means what happens? This center of mass, if you observe the formula carefully, then the center of mass is given by m1 r1 divided by m2 r2 divided by m1 plus r2. Here it will be depends on the masses of the particles, distances of the particles. Therefore, if you observe very carefully, if m1 r1 and m2 r2 both are same, then which condition is given? Which condition is correct? Here m2 is greater. If m1 r1 and m2 r2 both are same, r2 is less. That is the distance. Distance r2 is less, and obviously what? m2 is greater. Therefore, the correct option is bottom part has a larger mass. This is a correct option. Some theoretical questions are there which takes more time and it requires some basic definitions. If you clear that definitions and if you know the factors on which center of mass depends, then we easily get the answers of these questions. Just I will solve some examples. 2 theoretical questions are discussed and 2 to 3 numericals are discussed. I think it is sufficient. If you have any idea, then we discuss in the tomorrow's lecture. Just homework, solve this worksheet, or you, with the help of these examples, solve the numericals from the Singage question. Thank you very much.